Okay, today we are looking at simplifying complex radicals. Okay, in the past we looked at just simplifying radicals, but now we're simplifying complex radicals, meaning we have a negative underneath our square root. Okay, we're not allowed to have a negative under the square root. So the very first thing, anytime you have a negative under the square root, I want you to take that negative out, and I want you to put an I out front. Okay, that I means it's imaginary. So we're going to break down this. We're going to break down our square root of 48 just like we normally would. But now we need to represent that negative underneath with an I. So we've got 6 times 8 is 48. 6 breaks down. 3 times 2. 8 breaks down 4 times 2. And again, we're circling all of our prime numbers. And 4 breaks down to 2 times 2. So remember, we have an I on the outside already. What pairs get to team up and join him? I got a pair of 2's there that gets to team up and join him. I got another pair of 2's there that gets to team up and join them. And the only single prime number I have right there is my square root of 3. Now, anytime you have an I out in front, your I is always going to stay immediately in front of your radical, immediately in front of your square root. So on the outside, I have 2 times 2, which turns into 4, along with my I, square root of 3. So we break down our square root of 48 the same way. If we broke down just regular 48, we'd have got 4 square root of 3. But we need an I in front to indicate that there was actually a negative underneath that square root to begin with. All right, look down at number 6. Anytime you have fractions underneath your radical, okay, we're going to split these guys up. We're going to give 27 his own square root, and we're going to give 49 in the denominator his own square root. All right, we'll break these up individually. So 27 is going to be 9 times 3. 3 is prime. 9 breaks down to 3 times 3. Now both of those guys are prime. So we have all prime numbers. I've got a pair of 3's that get to team up and go out together as 1. And I've got a single 3 here that doesn't have a partner. He's got to go back home alone. In the denominator, square root of 49, we should know that off the top of our head is 7. Okay, and then in this case, anytime we have a fraction, we always look at our outside numbers, okay, and look to see if they reduce. In this case, 3 over 7 does not reduce, so there's nothing we can do there. So we split those up, give them each their own square root, and then break them down individually. Number 7 is very similar to what we learned last, just simplifying radicals, except here we have 2 variables. We split up our 52. We've got 2 times 26. 2 is prime. 26 breaks down 2 times 13. And both of those are prime. So our pairs here, the 2's get to team up and go out together as 1. My single guy here is 13, so he goes underneath the radical. Now, for the x's, I've got 3 of them. I got a pair here that gets to team up and go out together as 1. And I got a single guy here that's got to go back home alone. And for my y's, I've got 5 of them. 1, 2, 3, 4, 5. How many pairs do I have? I've got 2 pairs that get to team up and go out. So that's y squared gets to team up and go out. And I have 1 single guy left that's got to go back in. Okay, so that's how we do it with multiple variables. Break each one of them down by themselves. Now let's flip over to the back of this assignment. All right, we've got our notes here. Okay, we have our 4 I rules. Okay, our 4 rules for I. Anytime you have a negative underneath the square root, that's going to be an I. And it's okay to have I's in our answer. I's are fine. Negatives underneath the square root are not fine. Anytime you have an I squared, we talked about these in class, but anytime you have an I squareds are eventually going to turn into negative 1. We don't want I squareds, we want negative 1s. I cubed is actually going to turn into negative I, and I to the 4th are actually going to turn into positive 1s. Okay, so I've got those 4 I rules and then examples for each one of those there. Okay, so knowing that, we are going to look at problem number 11. Okay, so the very first thing I notice here is that I have negatives underneath my square roots. So I want to get rid of those negatives and put I's out front, just like we did on the front part of the page. Okay, each one of those we have get rid and we have I's. So if we multiply here, we've got I times I on the outsides, which is I squared. okay, on the I squared on the outside, which I squared, we look at our rules, we don't want I squared. I squareds need to turn into negative 1s. So actually, I times I on the outside, it's actually negative 1 on the outside. Now, to break these down, 3 doesn't break down, so 3 is prime. 15 breaks down, 3 times 5. Okay, so I had a negative 1 on the outside. Do I now have any pairs from underneath that can join them? Yeah, I got a pair of 3s that can join that negative 1 on the outside. And 5 is single, so he's going to stay in. So on the outside, I have negative 1 times 3. So I've got negative 3 square root of 5. All right, so we use two I rules there. First of all, the negative under the square root, bring your I out front and make this number a positive. And then we also use the I rule when we had an I squared. That I squared turned into a negative 1. Okay, we're going to look down a little bit further at number 23. Okay, so 23, we're multiplying here. Well, this says 7i squared. Well, that squared right there really means 7i times itself. And then we also have a 6i as well. Right? So I just want to rewrite the original problem. Okay, so now what I'm doing is I'm multiplying the coefficients. 7 times 6. And that's going to multiply to give me 294. And I'm also going to multiply the i's. So I times I is I to the third. Again, I to the third is not acceptable. So if we look at our rules, I to the third actually needs to turn into negative I. So this should be 294, not I to the third, but 294 times negative I. 294 times negative I, negative 294 I. And it's okay to have i's in our solution, but it's not okay to have I to the third, so that's why we changed it to a negative I. Okay, now when we get to these really big exponents, we talked in class by extending this I to the 5th, I to the 6th, I to the 7th, I to the 8th. Okay, and these 4 I rules continuously repeat over and over and over. I to the 5th is going to give you I. If we continued I to the 6th, it would be negative 1. I to the 7th, I to the 8th, I to the 9th, 10th, 11th, 12th. And we could continue doing that forever. But the shortcut would be, since those 4 rules just continue to repeat, the shortcut is to put it in your calculator and divide it by 4. So if we're looking at I to the 75th power, okay, what I want to do is I want to put 75 and divide it by 4 in my calculator. Okay, so what this is telling me is that I would repeat that cycle, repeat all 4 of these cycles. I would repeat it 18 times. I don't care how many times we repeat it. What I'm really looking at to see where it's going to end up, on which 4 of these it's going to end up with, I look at that decimal. That decimal is a 0.75, right? Or as a fraction, that would be 3/4. Okay, so over here off to the side, I wrote the fractions for each one. This is the first one out of the 4 that we learned. This was the second one out of the 4 that we learned. This is the third out of the 4 that we learned. And this was the 4th one out of the 4 that we learned. So 0.75 is 3/4. So it's going to be the third one out of the 4 that we learned. Okay, so I to the 75th power is the same thing as I to the third power, which is, we don't want that, we want negative I. That's going to be our answer. Okay, so take your exponent, divide it by 4, and look at what decimal it gives you. So if you get a 0.25 as your decimal, that's 1/4. Your answer is going to be I. If you get a 0.5 as your decimal, that's a half. Your answer is going to be negative 1 there. We just saw one that had a 0.75 as the decimal. And if you have a whole number, no decimal, it's a whole number, okay? That's what 4 over 4 is going to give you, a whole number. So if you end up with a whole number here, no decimal, then your answer is going to be a 1.